Hi friends, now let's get into the next session where we look at how an operating system is structured. So the structure of an operating system means the blueprint of the operating system, how an operating system is organized and how the components are interacting with each other. So the whole blueprint is put, and that is what we call a structure. So to begin with, the early version of the operating system was very crude, and it was working for a single processor, and the process was a single process at any given time. So any one process it used to work on, and that was a simple operating system structure where we began our journey. So as discussed in our previous video, the history of the operating system, or how the whole thing evolved, or how it all began. So if you look at that, it's just a simulation of all the functionalities and put together is one form. So that's all put under one basic input output system drivers. So this is a BIOS. It's usually a small bootstrap code which is written on the EEPROM or ROM. It's a read-only memory. It's a part of the motherboard, and whenever we switch on the system, it begins to execute the code from this, because by default it starts from some address location, and that address location belongs to the BIOS. And here we get the device drivers that necessary. So to begin with two devices are essential to work with any system. One is the keyboard and one is the monitor, because we want to give input to it and see what the system is trying to tell us. So these two have to begin with. So the basic input output device drivers are put on the BIOS, and once that is done, a small component of the operating system is put on that, and then we have other device drivers, and then the system calls and all that, and finally comes to the application program. All this here we have shown in some structural form, but in reality, the the first version of that was not well structured, and then it was very small and having limited features, and the interfaces and functionality were not well separated, so it was just made as one component. The all functionalities, whatever we wanted, just combined together to make it one software called the disk operating system or something like that. The advantages of such simple software is easy in the development and gives a better performance as long as you are working with the simple problems. But the negative part of that is lot of times the system may fail because of some malfunctioning, and it's difficult to maintain. So there is poor maintainability issues related with this. So to overcome this very crude operating system structure, we shifted to the next one, which we call a monolithic. So where what we have is one hardware, on top of that we have one kernel, and then on top of that we have application programs. The difference between this and the previous one is all the applications will be working in unprivileged mode, whereas the kernel operations are working in privileged mode. So privileged mode means they have extra say on the usage of the resources compared to the unprivileged mode. So any given time, two actions require to use any resource, one from the unprivileged and one from the privileged, then first preference will be given to the privileged mode request. Only when no privileged mode is requesting for the resource, only then unprivileged mode request will be served. Yeah, that's advantage of the second one. Here, all the functionalities are put under one kernel. The difference between this and the previous one is there was nothing like privileged mode, unprivileged mode. Everything was in one form of thing. But here we have a privileged mode, so all the kernel activities are taken care in privileged mode. So all the operating system functionalities are defined under one kernel. So single kernel, all services are defined in this kernel space. Linux, Unix, and all are examples for such thing. The advantage is it is fast, so there is less context switching required. We'll look into detail about context switching and all that in our future sessions. Direct access between the components is there and hence it will be useful. But the negative part of that is it is less secure because a bug in any of these modules can crash the whole system. So if there is a problem in file system, then whole system will stop working. If there is a problem in drivers, then whole system will stop working because everything is one unit, and anywhere or problem is there, then the whole system collapses. And the other problem is to maintain and update. It is too difficult. If we want to have a better service, say in file systems, then just we cannot change the file system component. We have to modify the whole kernel itself. That means while changing any one component, the whole thing has to be rewritten, and in that we may again create new problems by rewriting and all that. So that's one side. We have a privileged mode here compared to the previous one, but we have a problems like any bug anywhere is going to disturb the whole system and harder to maintain or update are the two problems mainly we can see in this. So to overcome these two problems, we need to go into the another one. So before going to the next one, let us check one example where we were working with an example of a restaurant. So imagine that restaurant where only one kitchen is there, which is huge in size and handles everything: cooking, billing, cleaning, supply ordering, everything is taken care at one place only. So it looks very fast, but definitely it is risky. If any one chef makes any mistake, then the whole kitchen may shut down. So that's a problem with what we call monolithic operating system structure. So to overcome this, we come across with another operating system structure which we call microkernel. Instead of having a whole thing as one kernel, you just define one microkernel where all the basic things are defined under the kernel. Only the basic things are defined under the kernel, and all other things are defined separately. So the common things applicable for all the functionalities are defined under the microkernel. So only essential functions are in the kernel, that is like CPU scheduling, inter-process communication, basic memory handling, etc. The essentials and compulsorily required things only are there in the kernel now. So now the size of the kernel is small, so we call it a microkernel, and other things are defined individually as a different modules. So if you are talking about device driver, then we have a separate unit called device driver, which is a link between application and the microkernel. So if there is any change in the device driver required, then only this component has to be updated without disturbing any other component. So that's the advantage of working with a microkernel. So only essential things run in the kernel space, and all other things run in the user space. So user space means they are less privileged, and kernel space means highly privileged. So the examples are Minix and other operating systems. The advantage is more secure and stable, easy to update, replace individual services. So we can just update any of the services individually without disturbing others. The problem is the overhead due to communication between modules. So between modules, there will be, if there are communication, then there will be a lot of overhead, because earlier all these modules were part of one kernel, but now they are independent entities. Then they need to interact with each other, so there will be more overhead and interaction between the modules, and definitely because of that the performance is little slower, because the kernel mode or the more privileged mode works only for essential functions, and all other functions are working at a user mode. So user mode means any kernel mode activity comes on the way, the user mode activity will be paused, and CPU is given to the kernel mode activity. So whenever any of these applications, a file server, Unix server, device driver, application, IPC, any of these are being executed, and during that time, if any of the kernel activity comes on the way, then this will be stopped and this will be taken up. So every time a kernel action comes, then the user actions are stopped. So that way the whole system becomes slower. So that's about the microkernel. Then we have an example for that. And here a microkernel can be taken up as a restaurant manager. He is only there to take orders and assign the tasks. So he just take the orders. Cooking, billing, cleaning, delivery are handled by external teams or the user space services. Only the restaurant manager working in the kernel mode, and all others are working in the user mode. If one fails, then rest can still operate safely. So if one table having a problem of cooking or billing or cleaning, other tables will be running without any problem. If one item is not properly cooked, at least other items will be cooked. So that is the advantage of working with a microkernel. So this figure depicts the difference between the what monolithic kernel and microkernel is. So we have hardware in the bottom, and then the blue one is talking about the privileged mode. So, and the monolithic device driver, dispatcher, scheduler, IPC, file system calls all come under the privileged mode. Only application is in the non-privileged mode. Whereas in the microkernel, only the microkernel is in the privileged mode, all others are in the user mode, and hence any disturbance is there for these, then it can be stopped. Whereas all these in the other side. All these are working in kernel mode. Therefore, once they start working, they cannot be stopped on the way. Whereas in the user mode, if it is working, it can be stopped temporarily and goes down to the kernel mode and then continue that work and complete that and come back and make the user mode activity continue working. So anytime kernel mode activity comes on the way, then the user mode actions will be interrupted. So because of these interruptions, the user mode processes always will be running very slowly, and the monolithic thing, everything is in the privileged mode, therefore it will be faster. But in this case, only few of the essential facilities are in the kernel mode, therefore there is chance of a lot of interruptions, and hence this whole thing will work slowly. The next operation will be about the layered structure. Here, the operating system is built in layers. So we have one layer of the hardware, then on the other we have CPU management layer, then memory management layer, device drivers, lever I/O management layers, and application layer, and so on. So in this case, the advantage of this is if any of the things have to modify, then independently we can just change each of these layers without disturbing other layers. So it is highly organized and easy to debug. So when you identify there is some problem, then you can easily identify which of the layer is responsible for that problem or for that bug, and it is easy to debug it and easy to solve the problem. Each layer can be tested and maintained independently. There is no dependency anymore. Each one can be separately tested. The disadvantage of this is less efficient due to strict layer to layer communication, because hardware cannot directly interact with the application, hardware cannot directly interact with the device drivers. It has to interact with the CPU management. CPU management in turn should interact with the memory management. Memory management should inform to the device driver. Device driver should inform to IO manager. IO manager only can communicate with the applications. So this is a layer to layer strict communication is there, and because of this it will be less efficient, and lower layers must be perfect, because the lower layers are directly more nearer to the hardware. If anything goes wrong on the lower layer, then the error can propagate up. So if there is a small error in the CPU management, then that error will be enlarged in the next layer. It will be further aggravated, further aggravated. By the time it reaches the application layer, the error might have gone multifold, and that becomes a problem. So that's pros and cons of layered operating system structure. So here, example can be a multi-story restaurant where each floor is having different actions, like ground floor handles all the raw materials, first floor may be processing the ingredients, the second floor cooks are there, third floor service serves the dishes. Each floor depends on the one below. So if you want ingredients, then it has to come from raw materials only. If you want to cook, then you need ingredients. If you want to serve the dishes, then it should be cooked. So the flow is the raw materials are there in the ground floor, they go to the upper floor, become ingredient, then go to the upper floor, they are cooked. Then the cooked things are served. So this is how it has to go. So you can't just bypass any of that. So it's directly from ground floor. If you go to third floor, it is like we are serving the raw material without cooking and all that. So that's it is very highly organized, but slower than one room kitchen. So that's analogy we wanted to give. So to summarize all that, if you look at the speed, the monolithic kernel will be the fast one. Layered operating system will be moderate in the speed, but microkernel is very slow because of every time it has to message, and most of the units are working in the user mode, and hence they are it is possible that they can be interrupted on the way, and every now and then if it is getting interrupted, definitely to complete any given task it takes more time, and hence it becomes slower. Modularity, yes, microkernel is highly modular because anything can be easily replaced and modified, and layered operating system is medium. Monolithic, definitely it is very poor maintainability. It is very difficult in monolithic, very easy in microkernel, very easy in layered, because we immediately identify exactly where the problem is, and how to solve that. It's very easy in both microkernel as well as layered operating system. As far as security is concerned, the microkernel is highly secure because in this case, very few things are working under the kernel mode. Layered operating system say okay, but monolithic is highly risky because any one thing fails, then everything will fail. Here they are working in parallel, therefore if one thing fails, then others will continue. So having a better security. So looking at the example, the monolithic kernel is Unix, MS-DOS, microkernel is Minix and Mac OS, layered one is Windows NT, that's a old version and all that. So that's all about the uh, structures of operating system, various types of structures of operating system. So please do like the video. If you like this, press the like button. Please subscribe to the channel and hit the icon button so that we share the notifications whenever new video in this series comes up. So please do like it and continue watching this. Thank you.